You have to solve this differential equation.
To get what?
To get this answer, I have given the answer, but giving answer is not needed for solving this, right?
What's the general format?
Is the first order one?
No, I mean
general
general
integration factor.
General equation.
The general equation is that one. That's the integration factor. Even I have given that.
No, general. No, there's a
General.
IX something.
I of x is this one, integration factor, which
No,
is x
no, no.
e to the power integration p of x is.
There's something like.
Right. Okay. Now we are divide both sides by. No, I am not. I don't say that, right? Yes, I want to check that my performance, right? I like to get that. That's why. Otherwise, no any other purpose, right? So then, the main purpose is to learn here, right?
There's general equation.
General equation is we can divide by, yeah, we have adapted according this form and this is first order one. This is applied when it is not separable. When it is not applied, it's separable.
There's another general equation.
Another general equation means that in this case we have applied this part because we can't apply the separable method in this differential equation, right? The other one is second order, homogeneous and non-homogeneous. We have those things as well. But then we don't have
No, I was asking about y equals cf plus pn.
what?
We should give it in that format. Y
We
equals
have keep that in this format, right?
y equals cf plus pn.
No, this is not a second order one. This is not a second order one. You have to check this thing, right? This one, right? See, check this. First order differential equation, but we can't apply separable method. Since we have failed to apply separable method of using a transformation. If we can't apply the separable method at once, then we can keep that according to this format and we can go through this through the integration factor. Okay, that's why I say always we have to do many questions, right? So even though we did questions, then you should get many more experiences, right? Please do it quickly. Yeah. Then we can divide both sides by x plus 1 first. Then this becomes minus 1 over x plus 1 into y e to the power x plus 1 squared over x plus 1. Since x is not equal to minus 1, this is going to be cancelled off. The other one is going to be cancelled off. You can see now it's according to that general format, which is dy by dx plus p of x into y equals q of x. That's good. Could you understand? Yeah. Then who is this p of x? This is p of x, right? This is p of x because this c is plus minus. It's plus minus, right? And this is q of x. This is q of x. Right? Is it being recorded? Yeah. No? So please keep doing this. Right. Then now you can multiply both sides by integration factor, right? When it comes to this position, you can find the integration factor, which is I of x equals e to the power integral p of x dx. E to the power integral p of x is minus 1 is written outside minus
What?
is minus 1 over x plus 1, right? So they have standard equations.
X plus 1 to the power minus 1.
This is ln x plus 1. This is ln x plus 1. That minus goes because the derivative of this is existing in numerator. The derivative of this is in numerator. The derivative of this is in numerator. That's the format. Just remember that if a prime of x is in numerator, this is the function in denominator. This is exactly the derivative of the denominator.
Yeah.
So then, what is that? Is ln?
ln.
Modulo f of x. Right? So now you worry about this modules because when you try to split them into two different parts, at the rest it's going to be cancelled off here, right? So I don't care, right? So then this is ln x plus 1 modulus, but when we keep this minus sign into this part, it goes down, right? Because it's to the power minus 1.
ln modulus 1 over x plus 1.
Yeah, 1 over x plus 1. Yeah. Then e to the power is cancelled off with that. Then finally you get the integration factor is 1 over x plus 1. 1 over x plus 1. Right. This is the integration factor.
Where did the minus go?
Yeah. Minus 1 goes in because it is ln modulus x plus 1. Right? This is ln modulus x plus 1.
Ln modulus 1 over x plus 1.
No, it is ln modulus f of x. Not 1 over, right? ln modulus x plus 1. When this minus goes in, according to this is a very ordinary thing, right? Don't forget these things. Right.
Minus ln plus x, so what happens?
Yeah, then minus goes in, then you can get the reciprocal because to the power minus 1. Ln to the power ln x plus 1 to the power minus 1. It goes down, then ln 1 over x plus 1. E to the power ln 1 over x plus 1 because this goes down, right?
What happened to modulus?
Modulus, no one care that. You know, when I was talking about that at the very beginning, we care the modulus, but otherwise it was cancelled off because on both sides, when you simplify this, on your both sides, you have the modulus and the rest according to this, right? It doesn't matter. If you worry about that, you can keep the modulus, and finally you can see that's going to be cancelled off, right?
So always cancel modulus.
Yeah, it doesn't affect because on both sides you have that. Finished. Yeah. After that, we can multiply both sides by integration factor, right? This is minus 1 over x plus 1 into y. I'm going to multiply both sides by integration factor. This is multiplied by integration factor. I don't need to write it down, but I know that is integration factor, right? Then your right hand side is q of x, which is e to the power x into x plus 1, and when you multiply this side by I of x is like this, then you know the I of x, right? You know the integration factor. Who is this guy? Yeah. Who is this fellow? Who is this fellow? Yeah.
That's
Yeah. You
that's
don't know.
I of x.
What? The derivative of this one into this one.
Yeah.
That's how we prepare that, right? I showed that I derived this general expression earlier. We differentiate and we check how it's going to be this one. So simply we can replace this exactly at once, right? It doesn't matter. Right, then this is I of x. You know I of x now. You can substitute it over there because we are going to integrate that. This is 1 over x plus 1. X is only equal to minus 1. This cancelled off. Then you can, even though it seems like it's cross multiply, it's not actually. It's regarding. There is a deep meaning behind that using limits, right? Because dy by dx is delta y over delta x, limit delta x goes to 0, then those fractions are going to the other way, right? So it's a very, there is a deep meaning behind it, but we don't used to go through that. Simply, it seems like it's like a cross multiplication. Seems like a cross multiplication, but it's not. So then you can integrate both sides. Right. Now we are close to the answer. You can replace this I of x with 1 over x plus 1 at the rest. Right. So now you can see that this modulus sign, why this modulus sign does not affect the answer, because on both sides you have that modulus sign.
So integration of e to the power x e to the power x. Right.
Yeah. This part is like an elephant, as I showed, because this is that part. That one should be integrated with respect to this part, which is same as this one. Right. Okay, then e to the power x is same as e to the power x, then this, right? Okay, then I of x is nothing else, 1 over x plus 1. Then this is the answer you got.
Yeah.
Y over x plus 1 equals e to the power x plus c.
Yeah.
C is an arbitrary constant. Is an arbitrary constant.
I'll do that alone.
Yeah, please. Then give me your paper. You don't have writing book? You don't have writing book? Give me this writing book and I can check out. Could you use this space? And check the other question.
So I uploaded this.
Oh, I'm not sure. In Sydney, yes, I wanted to do that for a long time. I didn't do anything regarding that. No need to think about this. Yeah,
This is 2 into e to the power minus x square. What is
yeah, that is. It is same as that one, right? Because we can't do it using separable method.
So no. I mean 2 into e to the power minus x
It's called
to the power what?
e to the power minus x is called.
Oh, is it?
Yeah,
Okay.
it is.
Okay.
I didn't check this completely. That can be. I think that can be integrated because that is coming up with the integration factor. Otherwise, e to the power minus x squared is a Gaussian integral. We have used double integral in order to find out the integral of e to the power x squared. It's a Gaussian integral. We don't have that in our Pythagorean, right? You have that in
University.
So that's the part behind the statistics. We have normal distributions. So we have everything in the table. But if we try to integrate that, we have to go through that Gaussian integral. Did you do this part last time?
Yes.
Did you repeat that question? You're at home. You have to do that.
Okay.
Right. Finished.
Yes.
Right. Okay. Starting.
No. Close enough.
Right. Rarely they give us differential equations. Those can be handled in separable method in this paper, right? So therefore we can't expect that because we have this much. So then basically they'll be giving us two major questions regarding differential equations. So mainly they'll be focusing this one and the second order homogenies and non-homogenies together, right? Finished.
Wait. It's an integration of 2x
Yeah. Division of 2x, my god.
is x squared.
Yeah, 2 is the constant that's kept outside, right?
So do we need a constant?
Constant can be taken
No,
outside.
I mean it's like c. After
Yeah,
integrating.
if it is a non-definite integral, you have to the constant.
So now do we have?
Yeah, of course. You know the integral of this, right? X squared over 2. So it's equal, right?
Yeah.
So these are going to be cancelled out.
So x
And we can prove that using summation, that series, that the sigma notation and the limits, we can prove that this is going to be this one, right? And normally we used to depend on this equation if x to the power n, since n is not equal to minus 1, when it is different integrated, it's going to be x to the power n plus 1 over n plus 1. We used to work with this standard form, it's not standard form like a strategy. We identify the strategy and we are trying to work through that, right? But that's not the way. If you realize that we should be able to prove it, right? From A to Z, but in the exam they won't ask that. The only skill you should gain is you should be able to integrate this, right? And if it is x cubed, x to the power 4 over, you know that. Then I think we should be able to aspect where you do that, right? limits. Right, shall I start working?
Okay.
Right. The same type of fraction. Right. This is p of x and this is p of x directly. Then you can find the integration factor simply e to the power integration to x dx. Right. This is the integration factor. 2 is taken outside. This is x squared over 2. 2 is cancelled out. Then e to the power x squared. Isn't it? But in this case, now I need to put the constant here, right? So you asked last time about this one. Do we need to put the constant? No, finally you can add the constant. And the rest is all. No, here no need to put that because finally you can include that. Right. Okay. Now we multiply both sides by integration factor. Integration factor dy by dx plus 2x into y into integration factor equals 2 into e to the power minus x squared into e to the power x squared, which is the integration factor. So this c is nothing else the derivative of y into I of x. It's going to be cancelled out because e to the power x squared is cancelled out with this one, right? So it is only 2, right? It's just 2. Then 2 into dx is a pretty similar, but pretty easy one, right? It's a pretty easy one when comparing the earlier one, right? So this is 2, then this is x plus c, then there is y into e to the power x squared, right? So this is solution. 2x plus c, yeah. You can put this into that, you can subtract y. So when it goes there, e to the power minus x squared. So did you get it? Yeah. The solution. Why? It didn't take too much time. Why? What's wrong with it? Let me check you. Oh, no. We don't put constant. That's why I said that. When you are working out with the integration factor, you only put that constant. Right? But finally, you can add it. It is a finally. When you get rid of this integration, you can add that constant. Right? Okay. What happened?
So integral factor now is
That's not needed here, right? Because we are trying to keep it according to the general format. In that case, we don't need the constant. Finally, we need the constant. If we have even a singular solution. Right. Shall we move to the next question quickly? Yeah.
okay.
So there are many more questions in this book. If you can get them. Otherwise, I put that these questions will be grouped, right?
Okay.
So all the questions, at least if you could do at least one question regarding each part per day.
Integration of 2 is to x plus c.
So, who's that? Let's move to the second question. last time did you do that complex number question once again? There was a loggers and unique per answer, right? And did I show you the easy method last time? I think we did it using only one method. I didn't use the other method. Okay, after this one we'll discuss the other method as well. Anyway, you got the answer right last time.
So can you keep the general format? The
General format.
dy over dx plus pxy equals qx.
What
Should it always be, can it be y cube? No, right?
what is this one? You mean? No. This is a question like that. You are supposed to show that using this one. You are supposed to show that this is right. So you can go for the higher order. This is the first.
This is not.
Your first derivative. You have to increase that up to third.
So we all use this one when there's.
Yeah. This is not differential equation actually.
Wait. So we only use this one when.
When the separable method is not applicable since it is in first order. Right? If it is second order, the others.
Second order means y cubed.
No, the second order means in such d squared by dx squared plus dy by dx right plus y equals maybe if it is a homogeneous one, this one is equal to 0. Is not, if it is not homogeneous, this is not equal to 0. Right? Do you remember this? Okay, we will be doing some more question.
There is a y cubed.
No. This is not a differential equation question.
This is not.
No, this is not. That's what I said. So using this one, depending on this one, you have shown.
Just
Yeah,
different.
just differentiate for the higher orders, right? Right. Okay, let's start.
Okay.
X into dy by dx minus y squared equals 4. Right. Okay, now you can hurry up. Come on. You can differentiate both sides with respect to x. Right? This is a multiplication. Right? This is a multiplication. X into this one is differentiated d squared by dx is 4 plus dy by dx is kept outside. X is differentiated, which is going to be 1. Minus, we have to apply chain rule. 2y into dy by dx equals 0, right? Okay, in this case, now you can see, and you have to check what is the
So what does it do? Did you differentiate it?
I differentiated both sides with respect to x. This is a multiplication. Don't remember, I gave you the equation for that, right? So in the formula we are going to only for the quotient, right? In the numerator, you can switch the sign. One of them is differentiated. This is kept outside, and the other one is differentiated.
Yeah, I know that.
Yeah, you know that.
Differentiated with respect to x means.
With respect to x means that y is differentiated with respect to x, it becomes dy by dx. That subject is x.
Subject is
Yeah,
x.
that means if it's a curve, this is a curve of this is a graph of x. Let's say it's a function of x.
It's dx over dy.
Yeah, but it's dy by dx. It's going to be differentiated with respect to x. With respect to x.
Just differentiate everything.
Everything with respect to x. With respect to x.
I don't
For
respect.
example, y equals, you know that, right? This term.
So can I not respect x?
With respect means normally then if this is differentiated, we can differentiate that with respect to different variables. For example, let's say this is going to be differentiated with respect to z. We can differentiate it. But we don't know that because we don't know whatever the correlation between z and x. But we can differentiate this with respect to x, right? This becomes this is one level we have this, right? So what are you talking about? Okay, just where I can ask any question with respect to dy by dx. It's nothing else, just dy by dx. Right, okay, now we can differentiate this one more time. How can we simplify this further? What do you think? Yeah, if you can factorize this, it doesn't matter, right? You can
minus 3y squared. You know, differentiate.
Yeah, then we can differentiate this one.
So say minus 3y
Yeah, because this minus is outside, then can we differentiate y square directly? Can we differentiate y square directly with respect to
minus
x?
2y.
Yeah.
Minus-
Can we differentiate this with respect to x directly?
No.
No. What do we apply there? What do we apply there? Chain rule. Who knows? This y square is a function of like y. So this is differentiated with respect to y, and then y is differentiated with respect to x. That's all chain. Chain rule can be applied for different positions, like differentiating composite functions, differentiating implicit functions, differentiating parametric functions. So this is what this is used for differentiating composite functions. And actually we can say, yeah, it's a composition. Because this is y squared. Y squared can be differentiated with respect to y. What is that? When y squared is differentiated with respect to y, what is it?
2y.
2y. That is what? 2y.
No, it's 3y means y cubed.
No, okay, then we have to differentiate this once again in order to get that expression.
No, I mean, it's y cubed.
Why is y cube? Oh, I didn't see, sorry. I'm very sorry about that, right? I didn't see that, right? This is 3y squared, yes, you could tell me that, right? It's okay, now, is it fine now? Minus 3y squared into dy by dx, right? This is y cube, then minus 3y squared, then minus 3y squared into dy by dx, that's all. Please differentiate this once again.
And 4 becomes 0.
Yeah, this becomes 0 because constant. 4 is a constant. 4 is not changed after anything. It's a constant. I think you are not familiar with millimeters if you come here back. It won't be changed, but the way of writing that down will be changed, but that behavior, the 4 is a constant, right? Like pi is a constant. They have different constant axioms like that. Like universal terms, they won't be changed. The way of writing that is not an axiom, so it can be changed. Finished? Yeah.
How do you differentiate the
Okay, come on. Right. This is again product, right? So again a product. We have to apply that once again. Yeah. Come on. X is kept outside. Then the second derivative differentiate once again with respect to x. It's going to be d cube y by dx cube. Then the second derivative is kept outside, closer to that. Then x is differentiated becomes just 1. And in the same way. You know the general form, shall I write down the general form? Right? I think I wrote that in your formula sheet for you, right? Okay, let's see. F of x into g of x, the derivative of this, right? Is f of x is kept outside and the g of x is differentiated plus even for partial derivatives. And partial derivatives we use the same equation. Why? What happened? Why you are frustrated? Don't give up, right? Come on. Right, okay. Then x into d cube y by dx cube. Now we are closer to that, right? D squared y by dx squared into 1 plus d squared y by dx squared. Again, this is a multiplication, minus 3 is kept outside, it's a constant. Y squared into this is d squared y by dx squared. You have to apply the product rule, right? The product rule. So dy by dx is kept outside, then y squared is differentiated now. 2y into dy by dx. Right. This is going to be dy by dx squared. Dy by dx squared. Right. Now I think you can separate them. You can arrange all these terms according to the given format, right? think this term is on the hand side, all the other terms can be put to the other side, taken to the other side. Then is x into d cube y by dx cube equals this one into the other side. Who's that? This is 6y dy by dx squared. This is 3y squared minus 2 d squared y by dx squared. Is it? Is it the answer? Yes, so sure. Yeah, then we have to arrange it. You have to check these coefficients, right? I didn't check that. Let's check it once. Is there a simplification issue? No. 6 1. Yeah, that's it. Yeah, that is it. So this is going to be 2. 2 into d squared by dx squared. What's the formula? Ay dy by dx squared plus dy squared. dy squared is c plus c d squared y by dx squared. Right, please. A equals 6 and b equals 3, c equals minus 2. I think ABC ideas to be well weighted, right? You have differentiate that concept.
So dy over dx dy over dx is dy over dx squared.
Yeah, that is differentiated.
No, dy over dx into dy over dx.
Yeah, that square of dy by dx. That's not the second derivative, right? And that doesn't become the second derivative because it doesn't make sense, right?
So d squared by over dx squared plus d squared by over dx.
This one. You're asking how this form?
No, when you add 2d squared by over dx squared.
Or when you add it.
When you add this
Oh.
before minus 3. The other two terms you have to add them, right?
Yeah, we have it. This is an apple, this is another apple, 2 apples, right? So very simple, right? Can't we pause this and again continue it?
Yes.
How do you do that? This key, ne? You can use this key. Do all those things, right? So let's go also. No, you have to understand this, right? Yeah. Could you understand? Right. So if there is a constant, you have to keep that outside, right? Okay, what's the other one? So there is a data series as well. show that, right? A, B, C are constant to be determined, and those are integers. Then A is 6, B is 3, and C is minus 2, right? Are they? You have the same constants.
Minus 2.
Did you get the expression?
Yes.
Right. Sure. Right. So I don't see that. That's why I
Yeah.
was.
Which one?
This is one.
Yeah.
This is right. What is this equal sign?
Electronics.
That's because it's zero. That's not there. Right?
No, it's
Don't
here.
make it messy.
It's
Don't-
here. See.
Yeah. Then who cares that? Right? So you have to interpret that properly. Otherwise, you won't get marks, even though that's correct. Interpretation is most important thing, right? Okay, because that's the way you can represent you are represented by that. You can't go there and tell this is there. Right? Okay, let's continue. Given that y equals 1, x equals 2, right? Given that y equals 1 and x equals 2, in this case you have to use the Taylor series, not the Maclaurin series, because the Maclaurin, I don't like to say that, Maclaurin copied, but in a media, then the Taylor, according to Taylor series.
I can use.
Yeah, please. F of x, f of a, dimension 1, f of f prime of a. This is x minus a, right? X minus a into f prime of a over factorial 1 plus x minus a squared, right? X minus a squared. Into f double prime of a over factorial 2 plus it comes up to infinity, otherwise sum of f the derivative is a derivative of f of x started with n is from 0 to infinity. It's from 0 to infinity. Yeah, that is the Taylor series, right? Taylor series. Maclaurin series is used when it is propagated about x equals c, but this is not propagated about x equals c. This is about x equals 2 only, right? Given that x equals 2 and y equals 1, x equals 2 and y equals 1. X equals 2 and y equals 1, right? Then you can find, I think they are asking for what? Until the third? Yeah. That's then when x equals 2, who is y? Y is 1, right? So that's what you have used here. This is f of 2. That is f of 2, right? This is f of 2 plus x minus 2, then f prime of 2. We need to find f prime of 2. Let y be f of x. Let y be f of x in this case, right? Then f prime of 2 over factorial 1. Plus x minus 2 squared is propagated above x equals 2. F double prime of 2 over factorial 2, likewise, up to which one we are supposed to get? Up to x minus 2 cube, isn't it? I'll check this 2. we have some questions here. We can get some mathematics, TNC's questions. We have until eigenvectors, eigenvectors, and the third one.
Live stream.
Yeah, live stream. No, live stream. I tried that first time. Okay, but yeah.
So, Monday.
Yeah, it's at 12, yeah. Is it okay for you?
If I can early, I will send a message.
Yeah, okay, then I can manage others, right? Then,
I will send the.
right. Then do those questions once again, right? Go through those questions.
Sir, can you send me another question?
Yeah.
No, I know the answer.
Yeah.
So I will not do the question.
Alright, right. I'll
Can you
ask you
send me
some.
some
Yeah.
question?
Tens and analysis. That keeps it that I mean not live for the outside guys. Using live. Live is all the things that I have this. Integral transforms. So we have numerical techniques. We can get some questions. Numerals, perhaps something that is 982. We had that in FP1, right? Shall we do one question? No, because these are exactly some extractions. Successive substitution method. This is known as successive substitution method as a in our conclusion they call that instructions method. So we have many example questions here. You get this? So the following equations by Newton's method. I can share these things here in the group, right? Yeah, what happens is the question. Then f of 2, who is f of 2? F of 2 is 1. F of 2 is 1. 1 plus x minus 2 or factor 1 is 1. F prime of 2, who is f prime of 2? F prime of 2, yeah, when x equals 2, when since x equals to 2 into, this is f prime of 2 minus 1 cube equals 4, which is 5 over 2, is it?
Yeah.
F prime of 2 is nothing else, 5 over 2, is 5 over 2, right? And plus x minus 2 square of factorial 2 is just 2. F double prime of 2, we had to do it on the third one, right? It goes up to, it's infinite, this is an infinite series, then only we can let it be coincident with the exact f of x, otherwise it's an approximation. Then f double prime of 2, who's f double prime of 2, we can use this equation, right? We can use simply this equation, we know this one is 5 over 2, this is f double prime of 2 plus x is 2, right? Minus 3 into 1 square into this is once again is 5 over 2 equals 0. Then also what did we get for this? 15 over 2, yeah, 15, 10 over 5. 5 over 2, again 5 over 2, isn't it? It's again 5 over 2. Yeah.
This.
C is 5 over 2 again, and finally 5 over 4, this is 5 over 2. What's the other one?
There
What's the
is
other one?
5 over 2.
Is it once again 5 over 2? Yeah. Is it again 5 over 2? Yeah. What?
35 over 2.
What? Right, okay. We'll use this one.
This 5 over 2.
This is, I trust your voice, right? This is into, otherwise then audience will blame me if there is something wrong in this implication, right? Then this one is 5 over 2 squared, right? Plus 3 into 1 squared minus 2 into the second derivative, which is 5 over 2, right? Second derivative is also 5 over 2, right?
Oh, super more. This is it.
Finally, it's divided by 2. This
That's
is,
it, right?
yeah.
That's it, right?
Did you get that? Can I check it? 6 into 5.
35 over 2.
Yeah, it's 5 over 2. Squared plus minus. This is 5 over 2, right? It's plus 5 over 2. There is a mistake here. In recording, this is divided into 2. What? What did you get?
35 over 2.
What? Easy. It's not anything. There must be something wrong in this. F triple prime of 2 is the third derivative at x equals 2. I got 20.
What? That's minus 1.
What?
3 minus 2 is minus 1.
3 minus 2 is plus 1. What? What? Since you have the calculator, you have to use that, right? So 20 over the factorial 3, which is 6, right? We can simplify this by 10 over 3, right? Isn't it? Right?
That's it, right?
Yeah, that's it. Not that one. So this is Taylor series, and the Maclaurin series is applicable since x equals 0. That's nothing else, it's the formation. It's formed based on Taylor series, right?
So after 11th, I'm not coming to class.
What?
I'm stopping.
Oh my god.
I don't want to.
Is it?
Yeah.
What's the reason?
I don't want
Oh, is it?
to. After 11th.
What 11th?
Yeah, so. Because I'm going over.
Then you know about it.
Because I know about it.
Yeah. I got to know that. Then you go to that. Then after that, how do I?
I'm coming second. Second I'm coming back.
Or is it?
September 2nd.
Alright, okay, then, wait, we arranged the class. I don't remember, we arranged the class just before. You go on Wednesday. You go on Wednesday.
No, I'm going on a Tuesday.
You go on Tuesday.
On a Tuesday.
We arranged that on Sunday.
Okay.
Morning time on Thursday. We will be missing only 1 week. Maybe
1 week?
Is it?
No, I'm missing like 2 or 3 weeks.
Is it? Oh my god.
11th to 2nd.
Then you don't have any idea to basically this time.
Yeah, not October. I'm doing a January 12th.
There will be specific as you.
You're going to get our results also in 12 more days.
That is a private discussion. I don't want to include it here. Joke ne? I thought that you are kidding. I don't know, did you finish? Right. I'm not going to edit this thing. There is no point of editing it. Did you finish? The final, yeah, we finished that. The other one is the mathematical induction question. Mathematical induction question.
3 hours.
Only 3 hours.
3 hours and 30 minutes.
Oh, it's a very short time.
Yeah.
I didn't have an idea about that geographical twist.
For US or something like 11 hours.
Is it? Right. Let's make this question. First, we have find partial fractions of 1 over n plus 3, 1 over n plus 3, n plus 5. Right? Did you find partial fractions of that? N over n plus 3. It's a very simple question. Like in order levels, we have these types. N plus 3, n plus 5. Okay, into n plus 5. This is needed to go forward. There are some more different possibilities, but I think this way is more easy. Compare these denominators are equal, therefore the numerators are equal. So then 1 equals a into n plus 5 plus b into n plus 3. Compare coefficients, then the coefficient of n is just 0, a plus b. The constant n is 1, which is 5a plus 3b, right? You can simplify these 3.
I got half.
A equals
Minus
you
half.
get half. Is it minus half? A equals minus half?
No, A
No,
is half.
A is
B
half.
is minus half.
Yeah, b is minus half, right? Good. B is minus half, then right. So when we substitute on this one, we get half n plus 3 and minus 1 over 2 and plus 5, right? Now,
No, I'll do this
yeah, okay.
next step.
Do it quickly, right? Don't take too much time. Don't take too much time.
So 1 over R I'll equate to VR.
Yeah, 1 over r.
Equal to VR.
UR is this. We have supposed to find the sum of r is from 1 to n, 1 over r plus 3, r plus 5. So this is UR. This is universal term, right? Then the n into pn plus q. P and q are integers to be determined, right? 40. Suppose for show this, we have used the method of inference is a very simple question, right? Okay, then who is we will write this down in terms of r because that is UR, right? So even though we worked earlier in terms of n, then we can switch them into r, right? Isn't it? Right. UR equals 1 over r plus 3, r plus 5. This is right, and it's same as 1 half. This is r plus 3 minus this is r plus 5. Right? This one is VR, and if this is VR, who is this? If this is VR, who is this? What?
VR plus 5. Yeah.
What? Easy.
What?
How is called, right? It's not change. If this is VR, who is this?
Minus VR.
What?
No.
When you substitute, instead of R, when you substitute, what is going to be equal with this one? Simply, if this is VR plus 3, this should be VR plus 5.
Oh, that is
That's
plus
the
2.
method. Otherwise, if this is VR, the difference is 2, right?
Yes.
So increment by 2. When you substitute, instead of R, when you substitute R plus 2, you get the other part, right? Other rational function. Right, okay. This is UR, use the method of difference. Use the method of difference. Method of difference. And since R equals 1, we need to start it with from 1 to n. U1 equals V1 minus V3. And R equals 2, then U2 equals V2 minus, and this is 2V4, right? And R equals 3. V3 equals V3 minus V5, right? So you can keep doing it like this. Continuously r equals n minus 2. Since r equals n minus 2, this is u n minus 2. Then this is v n minus 2 minus this is v n, right? Since r equals n minus 1, this is u n minus 1. This is v n minus 1 minus v n plus 1, right? Then this is u n. R equals n. R equals n. This is v n minus v plus 2, right? Okay, when you add these together, you can see these are cancelled off together, right? Minus v3 is going to be cancelled off with plus v3 here. This way likewise. What is the strategy? What is the strategy? This one is cancelled off, this one is cancelled off, likewise all these intermediates are cancelled off, and finally we get only this one and these two. These two and these two, right? So the sum of these, which is u1 plus u2 plus up to un is going to be equal with vn plus v2 minus what's this? Minus vn plus 1 minus vn plus 2, right? This c is nothing else. R is from 1 to n. ur is this one. We can rewrite it. In v1, who is v1? R equals 1. Since r equals 1 over 2 times 1 plus 3, right? Plus v2, who is v2? 1 over 2 times 2 plus 3 minus here r equals n plus 1. When you substitute r equals n plus 1, 1 over 2 times n plus 1 plus 3. This is minus 1 over n plus 2. We can replace this r with n simply, right? No need to substitute once again, right? N plus 5. Right, that's all. Then we can simplify this further. Right. What's this? You can use a calculator, right? This is 4 times 2 is 8. This is 8. 5. 10. This is 1 over 8. This is 1 over 10. It's the common denominator. What's the common denominator? Yeah, that is that's 40, right? That's 40. You can keep that as the common denominator. This is 40, and this is n plus 4, and this is n plus 5, right? N plus 4 and n plus 5. This is 40. What's it called? This one is 4 and 40 means this is 8. We can when you divide by 40, this becomes 5. And 5 this is 4. It's 9. It's 9 minus 2 means 20. This is 9 into this one, right? 9 into n plus 4 into n plus 5, right? Minus this is 20 minus 20 into what? This is 20 minus 20 into n plus 5. This is minus 20 into n plus 4, right? That's all. Now I can simplify this. Right. Here we simplify this. What's this constant? 20 into 9, right? 29. Yeah, here again 20 into 9, because there are 20 into 5s, there are 20 into 4s are going to be subtracted, they are going to be cancelled out. We know that, we can see that in our mind. Then this is n squared, which is 9n squared, right? So there must be certainly there must be a factor. This is a common factor is n, and is taken now in advance. This is 9n, 9 into 9 means 9 squared, 81. 81, these are going to be subtracted. 81 minus 40, we say 80 minus 40 is 40, but it is 41, right? It's 41 plus 41. You get the same answer or something different? I don't know, because there can be something wrong with my calculation, right? Please take it. I get this answer. According to this, P equals 9 and Q equals 41. The others are in the same format, right? Finished?
So,
You got it, right? You got it?
yeah.
Right? Now you have simplified it, right? Finished. Did you finish? Yeah, finished. No? What happened? What's wrong with it? Yeah? Tell me what's wrong with it. You have a calculator, that's in your weapon. Use this, please. Yeah? I'm not telling you how to do it, right? Yeah. What happened? What's wrong with it? See, answer with this one. Right? And we have only V1, V2, you got that? Yeah, that's fine. What is the common denominator in between these two? Let's see, it's 40. It's 40, then when you multiply this by 40, you get 5, this is 40, then 4, 5 plus 4 is 9, 9 into...
9 or 40.
Yeah, 9 or 40. 9 or 40, then into that one, because the common denominator from all, very all.
Yes.
Because other
So
fractions...
what are these?
Yeah, these are correct. These are correct.
So
You have to get common denominator for all. These are algebraic simplification.
what I want to do?
2? Yeah, I mean 2 contributes for that 40. The common denominator becomes 40 because of the others are 2, 9 and 2, 8 and 10. The least common multiple of 2, 8 and 10 is 40. That's why it becomes 40.
1 over 8 plus 1 over 8 is 9 over 40.
Yeah, it's 9 or 40.
So how does this contribute?
This is 9 or 40 and we see minus. So what is the common factor? Sorry, what is the common denominator? In between them.
20.
Is common multiple. Is common
20.
20. Is 40. Is 40. Into n plus 4 into n plus 5. Because this can be multiplied by 20. For denominator and numerator.
Yes.
So this is the common denominator. So then we have added all the other numerators and we have simplified. I did everything. This will be until you finish this part, I will pause it.
6.
Right.
20.
Finished.
So.
Okay, let's do this.
Experiment.
1 over 9.
21. 21 to 6 to 21. R equals 6 to n equals 21.
So this is very smart question. You can check the sequence of your answer using your calculator segmentation, right? 1 over 9 into 11 plus. Pretty short. 1 over 10 into 12, right? Plus 1 over what? After what? After infinity.
Is 6 to 21.
This is up to 1 over 24, 26. 1 over 24, 26. Alright, okay. Then this one start from, see, nothing else, the sum, the summation R is from 1 to, what's this, who's R? What's this one, then
6 to 21.
yeah, this becomes 6, of course. Yeah, that is 6. R is from 1 to, yeah, first of all, let's write this down. 6 to 21. 6 to 21. You are. But we have split this, right? It's like a chain, right? Because we know the equation from 1 to, it started from always 1 to. You are minus sum from 1 to 5. 1 to 5, isn't it? Then only we can get the, using this method, then only we can get from 6 to 23. 21st one, right? I'll give you, right? So then I'll show this one. This 21 n equals 21, then 21 into 9 into 21 plus 41 over 40. This is 21 plus 4, 21 plus 5 minus, right? This is 5. N equals 5. 5 into n into 5, 9 into 5 plus 41 over 40 into 5 plus 4 into 5 plus 5. This one. Then you can make sure that your answer is correct or not using sigma notation. In sigma notation, you can insert this one directly. Instead of UR, you can insert this part. It takes a little bit time according to math. Then you go there, you can use better calculator. Then you have time, then you can adapt it that because you can use the graphical calculators as well.
Yes.
Then some students are scared of that, scared of operating this because they are not familiar with those functions as well. But since you have some time, you can get one of them and practice, isn't it? Is there something wrong with the substitution? Is there something wrong with the substitution?
Check.
Then you can realize, will be released in this month. Yeah, it's vacation. They are released.
Yes. Same answer. Differential value is
Okay. Okay, shall I write my question? Did you make sure whether the answer is correct or not using the calculator for the previous one?
Yeah.
Implementation. Then you can get confused with that, right? Otherwise, if there is something wrong, you identify there must be something wrong with those things. You can get the consistency of those values of P and Q. You know they are exactly correct. If you get calculator value, say, okay. The transformation is given y squared equals 140. Sometimes, in some cases, transformations are needed because they can't be, we can't apply these models exactly at once, right? So even though it seems like that model, but we can't apply it. Even though this is the first order differential equation, it's not non-separable, but directly we can't apply it because when you check q of x, it's not a pure function, it's not a function of x directly, right? So in that case, we have to use what's that? Equals with xy squared or cube, xy cube, x y cube. So what's wrong with
y squared equals 1 over 2. That's the transformation.
Yeah, that's the transformation. This is transformation. Y squared equals 1 over 2. What is this? Y cube, right?
So
Okay, then
x
we
y
have
over
used
t.
that. Yeah, we have used that. Then how do you use it?
X y over t.
Yeah, we will turn this into dy by dt, shall we? We'll turn that into dy by dt, right? When you differentiate both sides with respect to t, this becomes, we apply the chain rule for this, right? This becomes 2y into dy by dt. Right? When this is differentiated, this t to the power minus 1 goes, comes in outside, and t to the power minus 2, this becomes a denominator which goes down, right? Then dy by dt, this is dy by dt, dy by dt is this one. Then, but we have to find that one, right? Dy by dt, so oh my god. You could use chain rule, or otherwise you could find dy by dx, right? This moment you will use dy by dx, right? You will use dy by dx, please. 2y into dy by dx, right? So here this is minus 1 t squared then dt by dx, right? This is right. Okay.
I will use dt over dy.
Yeah.
dt over dy not equals to.
No, here is dt by dx. This y is going to be eliminated from this system, right? Y is going to be eliminated from the entire equation. So,
dt over dx. How did you get it?
dt over dx.
Yeah.
Finally, I have differentiate both sides with respect to x. When this is differentiated,
So
this
there is
becomes-
no x there.
No x there. Oh, it's okay. Then you can apply chain rule. T to the power minus 1. So, when you are supposed to differentiate with respect to x, what you have to do? You can use chain rule, dx, dt by. That's why we have the chain rule, right? Linear chain rule. When this is differentiated with respect to t, this becomes minus 1.
Y is also differentiated with respect.
Yeah, I'm using chain rule, right? Could you please give me only 1 minute, right? I'll come back quickly. Okay, I came back. Oh. Right. Did you finish? Yeah. Right, now, there are many different methods. This one. Minus 1 over 2y d squared dt by dx. So, dy by dx is this one, right? We can replace it. We can draw there with this part. It's minus 1 over 2y t squared. So, we need dt by dx, that's why we do it like this way.
So how did you
Yeah.
differentiate that with respect to x dt to the power minus 1? I mean, with
This one?
Yeah.
Oh, this 1 over t is nothing else t to the power minus 1.
Yeah.
Right? So, this is the no, it's t to the power n, right? This one.
Yeah.
Right?
So
So that is applied. Minus 1.
with respect to x, how is it?
Not with respect to t. That's why we use the chain rule.
Then dt over dx, how did it come?
Using chain rule. Right? What we are supposed to do, we have to differentiate this with respect to, this with respect to x. Can you differentiate that directly? Can you differentiate that directly? With respect to x, can we?
No.
No, that's what I said. You can say. It's okay, it doesn't matter. You can do it, right? Okay. Then, okay, we will continue. Come.
I can remember this one.
Yeah.
Remember you?
Yeah.
Then,
Last April, you are on a basketball match where you showed us that. I saw some pics in the television.
Yeah, signals.
Yeah.
okay, how do we do that now then? I'm very sorry about that, right? Yeah, I thought that she will remain, but she came back, right? Okay, then look at this. This is what we have to do. We have to differentiate both sides with respect to x,
Yeah.
right? But we can't do that. So what we can do? or we can keep this x a little bit away. This is my chain rule, right? This chain rule, always we use this chain rule, linear chain rule. This can be differentiated with respect to t. So that's how it forms dt by dx. Forms dt by dx. That is needed for this one. Good job.
Great.
dt.
How do you solve dt to the power minus 1 over dt?
Oh yeah, isn't this one like?
It's the same as.
These things ordinal level, but why do we do these things ordinal level? So it's a simple equation.
Yeah, that's normal differentiation.
Yeah, normal
I
differentiation.
know this formula.
What? Since order we have that one.
Sir.
What a shame, right? What a shame. Then what a shame.
Oh my god. No.
If somebody knows that, then it's right.
No, I mean in terms of this like dt.
Yeah. It can be that variable can be changed, right? It doesn't matter.
I only know that variable. Oh my
Why?
god.
It's still I keep these terms in y because then when we cross multiply, when we multiply both sides by minus 2y t squared, this is going to be minus 2y squared t squared. This is minus 2 x y and t squared is there. Y to the power 4. And this y to the power 4. Then
So 1 over t to the
y to the power 4 is 1 over t squared, right?
Yeah.
So you can I need to rewrite it as dt by dx minus 2y squared. Y squared is 1 over t, 1 over t. 1 over that. Yeah, okay, 1 over t into t squared minus 2x into please give me a moment. Give me a moment.
Yeah, like before doing the presentation, I'll jot down the points.
You have PPT format, right?
Sorry?
You have PPT format with you. You have the presentation format, right? Microsoft.
No, it's like the same as we did for maths.
Oh, PDF.
Yeah, it's a PDF. Like
PDF.
PDF in the sense download.
Will you share that using projector?
Yeah, that would be fine. Anyways, I'm going to write in the board also.
Right. Then y to the power 4. We have to eliminate this y. Y to the power 4
Yeah,
is
for
1
instance.
over t squared. Yeah, this is cancelled off. Right now we can reduce that. You got that, right? You got that. I think you're supposed to show this one, which is in transformation. We can reduce that up to this format, right? Minus 2x. This is the one you got.
Yes, good.
Got it. Then this acts as y in this dy by dx minus a plus p of x into y equals p of x, right? First degree, the first order one, non-separable, right? P of x, you see, right? This is p of x. And instead of t, we have y. When we y, we have t. Instead
And
of
now
y-
we can use the.
No, now we can use this, right? Integration factor. You can multiply both sides by integration factor, same as we read the second order differential
Yeah.
equations, right? We have more time just before your vacation. We will do more, right? Otherwise, we forget when you come back.
Huh?
When you come back, we will forget.
Yeah.
One the guy,
Okay.
okay. Good. Then again, yes, Sunday.
Sunday.
Yeah, we added it. I don't know how it's said that because you're going to go this Thursday. That's right. Is going to be a beach.
No.
It's not there.
Not this Thursday.
Not this time.
Yeah, no, I have planned a trip, so I told him Thursday, but I'm going to change it to next Monday.
Then
He doesn't know yet.
inform me.
Okay.
Inform me when don't change the time.
Okay.
Because even it's not possible to come here.
Okay. Bye.
That's okay. Bye.
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 They're on Monday, right?
This one?
Yeah, this one they are issue.
Oh.
I have you.
Sir, tomorrow?
Even tomorrow. Tomorrow is Sunday.
Yeah, let's do last one.
Okay, if we are okay,
Okay.
then I will record that. Then I'm available to start with you.
Okay.
Only after easy talking.
Okay.
Can confirm, right?
Yeah.
And I added all the others, right? Right, okay. Right. Then, oh, even that is recorded. I didn't want it to be recorded.